Today, the Chinese remainder theorem, made easy. Here's a typical problem. X is equivalent to 2 mod 3, X is equivalent to 2 mod 4, and also X is equivalent to 1 mod 5. Find X. You need to understand modular arithmetic to understand the Chinese remainder theorem. So if you're not comfortable with things like mod 5, then have a look at my video, The Lazy Mathematician, or search for modular arithmetic on YouTube or the web. You'll also need to understand what the GCD, the greatest common divisor, of two numbers is. Now, to use the Chinese remainder theorem, we first need to check that every pair of modulos have a GCD of 1. So let's do that. The GCD of 3 and 4 is 1. The GCD of 3 and 5 is 1, and the GCD of 4 and 5 certainly equals 1. So we can use the Chinese remainder theorem to find X. Now, normally the Chinese remainder theorem is explained with something like this. Hard to understand, but I can make it easy. If I explain this problem, I think you'll be able to solve these problems forever. Okay, here is the key step. We will work out X in 3 sections. The first is the mod 3 section, the second the mod 4 section, and the third is the mod 5 section. For the first section, I would like to be able to ignore the second and third sections when I apply mod 3. One way I can do that is to include 3 in the second and third sections. Since 3 mod 3 is 0, when I zap X with mod 3, the second and third section will disappear, and I'll be left with just the first section, which is what I want. For the second section, I want the first and the third sections to disappear when I hit X with mod 4. So I'll include a 4 in the first and the third sections. You can now see the third section has 3 times 4. Sure enough, if I apply mod 3 or mod 4 to X, then the third section will disappear, as I want. So to finish this step, I will multiply the term in the first and the second sections by 5. Then when I zap X with mod 5, the first and the second sections will disappear. So now let's do the multiplications to clean this up. Let's just focus on the question for a moment and keep in mind what we are trying to achieve with X. Firstly, we want X to be equivalent to 2 mod 3. Well, if we hit X with mod 3, we know that the second and third sections are divisible by 3, so they'll go to 0. All we are left with is 20, which is the same as 2 mod 3. So if I stop now and just added up the 3 numbers, I would have an X that is equivalent to 2 mod 3. Now let's consider modulo 5. If we zap X with mod 5, then all we have to worry about is the third section. Well, X mod 5 will be equal to 2, but we want it to be 1. So all we have to do is find some number to multiply 12 by, so that 12 times that number, mod 5, is equal to 1. Well, 12 is the same as 2 in mod 5, and by trial and error we can quickly find that 2 times 3 is 6, which is equivalent to 1 mod 5. So if I multiply the 12 by 3, then everything will work out when we zap X with mod 5. Finally, we need to make sure that X is equivalent to 2 mod 4. Currently, X is equal to 15 mod 4, which is the same as 3 mod 4. I would suggest that you do this bit in 2 stages. Firstly, let's go from 3 mod 4, which we've currently got, to 1 mod 4, and then we'll go from 1 mod 4 to 2 mod 4. Well, 15 is 3 mod 4, and if we multiply 3 by 3, we get 9, which is the same as 1 in mod 4. So let's go ahead and multiply the 15 by 3. Now if I zap X with mod 4, I'm going to get 1, but I want 2. So to fix this up, all we do is multiply the middle section by 2. Now X mod 4 will equal 2, and we're now done. If we now add all this up, we find that x equals 146. Sure enough, 146 is equivalent to 2 mod 3, 2 mod 4, and 1 mod 5, as we want. I'll leave you to check that this is correct. You might ask, is 146 the only answer? Well, no. Since we are dealing with mod 3, 4, and 5, if we add 3 times 4 times 5, which is 60, to 146, we get 206, and that will also work. In fact, we can add any positive or negative multiple of 60 to 146, and it still works. So x is actually equivalent to 142 mod 60. That's the answer. Now, 146 is equivalent to 26 mod 60, so a nicer way to express the final answer is that x is equivalent to 26 mod 60. And by the way, there are no other answers. Let me make one final point. If the numbers were large, maybe very, very large, then everything still works easily except one part. When we needed to find a number to multiply 2 by to get 1 mod 5, we used trial and error to find the 3. What we were doing is actually finding the inverse of a number in a certain modulo. If the numbers are large, this won't work. Recently I had to work out what to multiply 11 by to get 1 modulo 7,171. Here you need to use the extended Euclidean algorithm. I'll say that again, the extended Euclidean algorithm. At some stage I'll do a video on finding inverses in modular arithmetic, but in the meantime you can search for it on the web. That's it for the Chinese remainder theorem made easy. I hope you found it useful.